Hello and welcome to Algebra 2 Lesson 41. In this video, we're going to learn about factoring by grouping. All right, so again, for most of you that took an Algebra 1 course, you've had experience with factoring by grouping. It's not a very difficult concept. It's something you just have to do enough practice with. So for factoring by grouping, the very first thing you want to do, you want to look for the GCF, again, the greatest common factor of all terms. Now, when this is not a 1, or we could also say when it's not a negative 1, you want to factor this term out to begin. So what are we saying here? Well, let's say if we had a 4-term polynomial and everything had an x as an example. Well, you'd want to pull that out before you even start doing anything because that's common to everything. When you don't do that, you're going to end up with additional factoring after you do the process, and you might miss it. Okay, and that's going to give you only partial credit on your test, your homework, whatever you're working on. So you want to always make sure you pull things that are common out first before you go into the steps. All right, now here's the next part, and this is where it gets a little confusing. You want to arrange the terms into 2 groups of 2 terms each. So this is for a 4-term polynomial. So you'll have group 1 and group 2. Now I have such that each group has a common factor. Now, in some cases, that common factor might be 1 or negative 1. The whole goal is to end up with a common binomial factor, okay? So you're going to have to play around with this a little bit. This isn't something where you can just kind of read a procedure and it's always going to be the same. So I have here that you'd factor the GCF out of each group. Again, that might be factoring out something that's not 1 from one group. It could be factoring out 1 from another group. And I have here, we should be left with a common binomial factor. Now, if you try a certain configuration and it doesn't work, I have here in some cases, we must try a different grouping. So don't get discouraged right away, or don't say, oh, this isn't factorable right away. A lot of the problems you're going to see, especially if you're in a section on factoring by grouping, are going to be factorable. You just have to change around the terms. Let's look at the first example, and this one's pretty easy. I'm going to start out by just going with the way things are presented, and I'm going to show you that you can do this multiple ways. So we have 18n cubed plus 21n squared minus 6n minus 7. So again, the first thing I want to think about is there something other than 1 or negative 1 that I could pull out from every term here, set it outside of some parentheses? The answer to that is no. And what I look for right away, I see this 7 here. The 7's a prime number. So I know that it's only divisible by itself or 1. Could I pull a 7 out from this 6? No, 6 is 2 times 3. So I can just stop there. I know I'm not going to be able to pull a number, again, other than 1 or negative 1 out from every single term of this polynomial. Now, variable-wise, you see that you have an n, an n, and an n, but I don't have an n here, so that's not going to work either. So we're not going to be able to pull anything common out to start. All right, so then we kind of go into our grouping. So I think about the first 2 terms as a group. So we could say this is, group 1. And then I think about the next 2 terms as a group. So let's say this is group 2. So in the first group, or group 1, what could we pull out? Let's just say this is a separate problem, and we go back to what we were learning in the last video, where we factored out the GCF. Well, if I think about 18 and 21, they have a common factor of 3, right? 21 divided by 3 is 7. 18 divided by 3 is 6. And 6 is 2 times 3, so I can't go any further. So if I pulled out a 3 and put that out in front, and then variable-wise, I have n cubed and n squared. The variable is the same, so I know I'm going to have an n. And the smallest exponent is a 2, so it would be squared. So let's say I pulled that out from that first group. What's left? What are the 2 terms inside now? Remember, we can use division. 18 divided by 3 would be 6. N cubed divided by n squared would be n. Then 21 divided by 3 would be 7. N squared over n squared is 1. So I've factored the GCF out from group 1. I've written it like this. Now I'm going to put plus. From group 2, negative 6n minus 7, what could I factor out? What's the GCF there? Well, 6 and 7, you're not going to get anything out of there other than 1, or you could do negative 1. You can't do anything. 7's prime, 6 is 2 times 3. The n is only part of this negative 6n. There's no n over here. So in this particular case, I'm going to try 1, and then I'm going to try negative 1 to see if I end up with a common binomial factor. It's obvious because the signs here are positive and positive that I need to pull out a negative 1, right? Because this is a negative and this is a negative. So if I pull out a negative 1, what's going to happen is the sign of each term in here is going to change. Negative 6n divided by negative 1 is 6n. Negative 7 divided by negative 1 is positive 7. So now, if you look, we have the quantity 6n plus 7 and the quantity 6n plus 7. So we have a common binomial factor. And just like when we factor anything else out, we can just pull it out. So let's pull that outside. So we'd have 6n plus 7. And if I've pulled that out, well, then this is left here. So I'm going to start another set of parentheses and say this is left. So 3n squared is left. Then I have my plus. And I'm left with, if this is gone, I just have the negative 1. So I can put plus negative 1, or most of you would just rather write minus 1. Doesn't really matter. And I'm left with the quantity 6n plus 7 times the quantity 3n squared minus 1. Okay, very, very easy. Now I want to show you a different grouping and show you that there's alternative ways to kind of get the same answer. And another thing you might want to do, you might want to pause the video and you might want to FOIL this and prove to yourself that it goes back to this. A lot of students have trouble believing that. So let me erase this as well for right now. We don't need that anymore. And let's say you started this problem out by saying, okay, well, I have an 18 here and I have a negative 6 here. Well, each of those would be divisible by 6. So those should be in a group together. Okay, those could be group 1, for example. And then you might say, okay, well, this has 21 and this has a negative 7. Those could be a group because each is divisible by 7. Okay, so let's try it that way. Let's make group 1 18n cubed. Then you'd have minus 6n. Let's make group 2, we'll have plus 21n squared minus 7. So this would be your group 1. And now this would be your group 2. So from group 1 now, I can pull out a 6n. So if I pulled out a 6n, what would I have? Again, 18n cubed divided by 6n would be what? That would be 3n squared. And then negative 6n divided by 6n would be negative 1. Then we'd have plus, from group 2, I can pull out a negative 7 or I can pull out just a 7. And it's just a matter of the signs. Now, if you look at group 1 and what we pulled out, the binomial inside the parentheses is positive then negative. If I pull something out here, I'm going to want that same configuration. I'll want positive then negative. So seeing that, I know I want to just pull out a positive 7. So pull out a 7, and what would happen? 21n squared divided by 7 is 3n squared. Negative 7 divided by 7 is negative 1, so minus 1. And again, you get your common binomial factor of 3n squared minus 1. Again, that's what you have right here. If I factored it out, I would get the same thing as I got here, right? I'd pull out the 3n squared minus 1. It would be there. It'd be in a different position. It'd be in the first position here, but that doesn't matter. The order of multiplication is irrelevant. Then I would have the quantity 6n plus 7 as my other binomial, and that's what I have here. So either way you do that, you end up with the same answer. So a lot of different ways to kind of rearrange things and make things work. All right, let's take a look at another one now. So let's suppose we had 49x cubed plus 35x squared minus 42x minus 30. So again, the first thing I want to think about, is there anything that's common to everything? I know 49 is 7 times 7. So again, 7 is a prime number. So I go through and look at everything. 35 is divisible by 7. 42 is divisible by 7. But 30 is not. So I can't pull anything out number-wise. Variable-wise, it's the same. I've got x, 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 but no x here. So I'm not going to be able to pull anything out other than a 1 or a negative 1, which again, it's a waste of time at this point. So now I would think about, okay, I want two groups of 2 terms each, where each group has a common factor. Now again, that common factor might have to be 1 or -1. So I would start by thinking about, okay, if this was a group, let's say this was group 1, what could I pull out? Let's just say I pulled out a 7, because both of these are divisible by 7, and then an x squared, right? They each have an x. The smallest exponent is a 2. So 7x squared. What would that leave me with? 49 divided by 7 is 7. X cubed divided by x squared is x. And plus 35 divided by 7 is 5. X squared divided by x squared is 1. So let's think about group 2 now. So this is going to be group 2. And our goal is to pull something out to where we end up with a 7x plus 5, that quantity. So what could we do? When we think about what's common, the first thing is if I have 42 and I have 30, number-wise, the greatest common factor is a 6, right? Because 42 divided by 6 is 7. That's a prime number. 30 divided by 6 is 5. That's a prime number. So the best I could do is pull out a 6. Now, one thing you want to notice is if I pulled out a positive 6, the two terms inside the parentheses would be negative. The two terms inside the parentheses here are positive, so I could just do the opposite of that, just pull out a negative 6. And what's going to happen is the two terms inside the parentheses would be positive. Negative 42x divided by negative 6 would be positive 7x. Negative 30 divided by negative 6 would be positive 5. And voila, I get my common binomial factor of 7x plus 5. So now I just want to pull that out. Again, just pull that out. If I have the quantity 7x plus 5 outside, and then inside the parentheses, what's left? Okay, you think about what's left. We'd have a 7x squared, and then you'd have a minus 6. Minus 6. So this factors into the quantity 7x plus 5 times the quantity 7x squared minus 6. And again, this isn't the only way you could have done that. I could have rearranged this into two different groups and gotten the same result. So let's say I did 49x cubed and then minus 42x. That's a group. Each would be divisible by 7x. And let's say I did another group where we have 35x squared minus 30. Each is divisible by 5. So in the first group, I would pull out a 7x, and I'd have 7x squared minus 6. In the second group, I'd pull out a 5, and I'd have 7x squared minus 6. So what do I get? Again, I have that common binomial factor of 7x squared minus 6, which matches this. And then if I pulled that out, I'd have a 7x plus 5, which matches this. So again, I'm just showing you in a lot of cases, there's more than one configuration that's going to work. All right, let's take a look at another one. So suppose we have 75ab minus 30 plus 45a minus 50b. So the first thing again, is there anything I can pull out before I get started? Well, in this case, there's going to be. Every number here involved ends in a 5 or a 0. So I know everything's divisible by 5, so I could pull that out. So if I pull out a 5 to start, 75 divided by 5 is 15. So this would be 15ab minus 30 divided by 5 is 6. Plus 45a divided by 5 would be 9a. Minus 50 divided by 5 would be 10. Then times b would be 10b. So we pull that out before we even begin. Continuing, I do my normal process with the inside part. Forget about the 5 outside. That's just going to multiply whatever the result of this is. So inside here, let me just write the 5 again. I'm looking for two groups of 2 where each group has a common factor. And again, that common factor might end up being 1 or -1. Now, one thing that you would see right away, if I look at 15ab and I look at -6, they don't share a b. Okay, only a b in this term. If I look at 9a and -10b, again, they don't share a b. I'm going to want to put the terms with b's next to each other. Let me show you what happens if I don't. So 15ab minus 6 plus 9a minus 10b. There's no way to factor this the way it is. If I look at this group of 2, I could pull out a 3. Okay, I could pull out a 3. And what would be left is 5ab minus 2. But over here, I can't pull out anything. So plus, I could pull out a 1 if I want, or a -1. Let's just try 1. So 9a minus 10b. I don't have a common binomial factor here, so I'm kind of stuck there. What I need to do in this situation is just rearrange things, okay? So I'm going to put 5 times inside of parentheses. I'm going to put the terms with b's next to each other. So 15ab minus 10b. And then I can put minus 6 plus 9a. So now let me kind of scroll down and get some room going. If I look at this first group, what can I pull out? Well, I can pull out a 5b. So 5 times, I'd pull out a 5b from there. And inside the parentheses, 15 divided by 5 is 3. ab divided by b would just be a. Then if I did negative 10b divided by 5b, I'd have minus 2. Now from this next group, I can pull out a positive 3 or negative 3. Let's just start by pulling out a positive 3. So if I pulled out a 3, I'd have negative 6 divided by 3, which is negative 2. Then 9a divided by 3 would be plus 3a. Now, a lot of you at this point, if you came to this, would say, oh, I don't have a common binomial factor. But pay close attention here. You have 3a minus 2, and you have negative 2 plus 3a. Those are the same. Remember, if I'm adding, I can switch the order. If I just switch the order here, okay, and just change the terms around, I've got the same thing. So I can just put 3a minus 2. 3a minus 2. And now I have a common binomial factor. So if I factor that out, remember the 5 stays out in front, I would have 3a minus 2. 3a minus 2 times, again, if I pulled this out, what's left? Well, I have 5b plus 3. So 5 times the quantity 3a minus 2 times the quantity 5b plus 3. And again, there are scenarios where you have to change things around, otherwise it will not work. And that's a perfect example. So I just wanted to quickly come back up to the original problem, and I want to show you what happens if I don't pull a 5 out to start. If I don't pull a 5 out to start, we already know that I can put these two next to each other and these two next to each other, and I will get a common binomial factor. So let's do that. Let's do 75ab minus 50b. And then let's switch the order here and just put plus 45a minus 30. So from the first group, if I think about 75 and I think about 50, I know that the GCF is 25. So 25, and then I know that I have a b here and a b here. So let's do 25b. So 75 divided by 25 is 3. ab divided by b is a. Then minus 50 divided by 25 is 2. b over b is 1. So from these two, 45 and 30, I know that I could pull out a 15. So if I pull out a 15, I would have 45 divided by 15, which is 3, then times a. And then negative 30 divided by 15 is negative 2. So let's continue here. I've got a common binomial factor of 3a minus 2. All right, so that would come outside. So 3a minus 2. And then what's left when I pull that out? Well, I'd have 25b plus I'd have 15. Now you might say, well, okay, that's fine. It's not. Whenever you factor, you must factor completely, okay? So is there anything else that I could pull out from 3a minus 2? No, there isn't. Is there anything else I could pull out from 25b plus 15? Yes, there is. 25 is divisible by 5, and so is 15. So I would actually have to pull a 5 out from this and say that, and I'm just going to switch the order to make this convenient. I'd have 5 times 25 divided by 5 would be 5, then times b, plus 15 divided by 5 is 3, then times this other 3a minus 2. So if I reported this as my answer, which is a common mistake, I'm not going to get full credit because I didn't factor completely. When I look at this answer, 5 times the quantity 5b plus 3 times the quantity 3a minus 2, I've factored completely. Nothing else I can take out of here, nothing else I can take out of here, right, other than 1 or negative 1. And again, that's why I preach to pull something out if it's common when you begin, because then you don't have to worry about this happening at the very end. So let's just look at one more, and we're just going to wrap this lesson up. So we have 56n squared ab minus 40n squared ma plus 70n squared a squared minus 32n squared mb. So let's see if we can pull anything out. 56 I know is 8 times 7. And I know 8 is 2 cubed, but let's not go that far. 40 is 8 times 5. 70, I would think about 10 times 7. And 32 would be what? 8 times 4. Now, forget about the 7 and the 5. That's not going to work. Everything is divisible by 2. I can pull out a 2 to begin. Now, variable-wise, I start with n. This has an n squared, n squared, n squared, n squared. I can pull that out. Then I think about a. So I have an a here, an a here, and an a here, but not an a here. Then I think about b. A b here, but not here. Then I think about m, and there's no m here. So really all I can pull out is 2n squared. That's fine. So inside of parentheses, 56 divided by 2 would be 28. N squared over n squared is 1, so I just have 28ab. Then we have minus. You think about 40 divided by 2, that's 20. N squared over n squared is 1, and then you'd have ma, or you could write am, doesn't matter. Then plus, 70 divided by 2 is 35. N squared over n squared is 1, and then a squared. Then minus 32 divided by 2 is 16. N squared over n squared is 1, so you'd have mb, or you could put bm. Okay, so let's think about if we had a group here and a group here. Would that work out? Well, I just think about the variables for a minute. If I look at this one right here, I pull out an a, I would have a b and an m. I can't pull any variables out here, so I'd be left with a squared and bm. So that configuration is not going to work. I don't need to waste my time. So configuration-wise, what I want to think about is putting these two next to each other because they each have an m. So I'd be left with an a and a b if I pulled out the m. With these two, they each have an a, so if I pulled out the a, I'd be left with a b, and I'd be left with an a. So that's what I want. You can see that that would work out. Might have to change the order around, but again, if you're adding things, that doesn't matter. All right, so I want to flip the configuration. Let's do 2n squared. Let's take 28ab, and let's stick that next to plus 35a squared. And just for the sake of completeness, let's go ahead and just rearrange that. Let's say we have 35a squared plus 28ab. Let's do it that way. Okay, then next I have this minus 20am. So let's put plus, I'm just going to put this in parentheses, negative 20am. And then minus, you have this 16bm. So from the first group, I'm just going to copy 2n squared. So from the first group here, I could pull out a 7a. What's left? 35 divided by 7 is 5. A squared over a is a. Then plus 28 divided by 7 is 4. ab over a is b. Then plus. From the second group, I can pull out a negative because both of these are positive. So let's do negative. And then 20 and 16 are each divisible by 4. So let's do negative 4. And then there's an m that's common. So negative 4m. So inside I'd have negative 20 divided by negative 4, which is 5. am over m, which would be a. Then negative 16bm divided by negative 4m is positive 4b. So what do I have here? I have a common binomial factor of 5a plus 4b. So this will be 2n squared times, if I pulled this out, I'd have that 5a plus 4b. And then what's left? Well, I'd have 7a plus, over here, I would have negative 4m. So I'm just going to write minus 4m. So we end up with 2n squared times the quantity 5a plus 4b times the quantity 7a minus 4m.